So I'm going to just go through a series of these and show you how to show you what the correct cross contour lines would look like. Most of this looks good. It's just right here. This would be straight down, like, and then I would, instead of going too close at first, you can go a little bit further out first. And then if you need to come back in and add a line, you can add it in between, so you have a little more control over it. Okay, so the only issue with this is that these lines are just not arcing enough around the contour of the object. So it helps if you turn your paper sideways when you're going to do arc. You see the pivot in your hand? I'm able to utilize the pivot in my hand to get those convex curves. And then these are all look good. So then the inside would be curved like that. And then, yeah, I just correct. These cross contour lines, they're just a little too flat. They wouldn't come to a point right there. So the behavior is that it kind of curves. So it's a front arc of an ellipse. And it is true that as you get closer to the horizon line or your eye view that it flattens out, but this is not flat here, so the curvature of these lines have to still maintain that consistency. So with these, see how the ellipse degree is pointed upward? So the ellipse degree on these would also be pointed upward. It would be straight here and then it would go back to being pointed upward, but these would be pointed upward too. Because the horizon line, you can tell the horizon line is up here somewhere because the degree of this angle of this ellipse up here is open. So if you can see, you know, if it's not a straight line, so an ellipse right at the horizon line looks like that. And above the horizon line you can see the bottom. And below the horizon line you're going to be able to see the top. So for these shapes, this is pretty good because look how, well, in the still life, the reason for these circles here aren't just random. You don't just put random circles there. The reason for the circles is because they created the arc of where the bottle caves in. This is a glass bottle, and this is not a sharp corner on the glass bottle. It's a concave curve. Okay. So the purpose of these circles were to create an even concave concave curve where the neck of the bottle meets the shoulder of the bottle. And then again, so with the cross contoured lines, these are going to be concave curves not coming to a vertex. Right? So they have an apex at the place where the curve changes, not a vertex, not a line. Sorry about the stupid yard work. I don't have time to wait, so we're have to deal with the yard work. I'm house sitting somebody else's house, and I don't have control over the atmosphere. Okay? So that's what this area would look like here. And then again, these arcs are just kind of randomly stop. So I'm going to twist it sideways so I can see it. These are ellipses. See that? They're ellipses, and so they come to a slight curve at the edge. They don't just randomly stop. You see how I'm ghosting the motion of an ellipse first? And then you just have to follow through, right? Just go through the forms that are covering it to get the right elliptical motion. If you try to arc it, look what happens. It curves up instead of having the right curvature. It abruptly curves up. Okay. And the same thing goes for these up here. Okay. So, and again, with the pill bottle, you just have this random line that just stops in the middle of nowhere, but actually what that is the front arc of an ellipse. So the ellipse, an ellipse looks like this, right? So that's an ellipse. See how it curves right there? It doesn't just stop. I know it's hard to draw those when you're first starting out, but it's okay that you didn't. I just want you to understand what's going on. So even if you have good cross contours in the field, if you just stop randomly at the edge, it's still going to give that illusion that the object doesn't have, volume, that it's kind of flat. And then instead of doing all that, I would just to convey that it's a flat plane at the top, right? So just to convey that these are flat planes at the top, you don't have to do the crisscross. That makes them look like they're flat. Okay. And so for the most part, these are correct, right? So I'll just go ahead and draw over them. And we are conveying this bend in the form. So the reason why this is a straight line is because if it's at your eye view, the cross section of something right in the middle is going to look like a straight line. So look at this cross section, really. I'm going to draw the cross section of this bottle just to show you. So the cross section, say, of this vessel right here at this point. So we'll draw this outer contour line, and then and then we cross over in the back, and then this is the hidden plane in the back surface. So this is hidden in the back. I'm going to try to do dotted lines. Okay, so you see how this is a cross section, this area here? Right down the middle of the bottle is a cross section that's flat, because it would be like you sliced it right down the middle. Okay, so that's a cross section. I'll get rid of this blue lines. Okay, and then the cross contours, I'm going to turn this sideways so that I can have a good range of motion. Again, see how they're just coming flat to the edge. This is actually, oopsie. So what you're looking at here is actually an ellipse. You just can't see the back edge of the ellipse because it's hidden. So along those edges, okay, there's that curvature on the edge happening. It's not just a straight line. It's the apex of an ellipse that you're looking at. Okay. So it just gave me an idea. Next time, maybe I make the students do the cross sections in the middle first before they do the cross contour lines. Okay, so I'm not going to do this back bottle, right? I'm just going to leave it like that for now. And okay, so I'll just correct this real quick. So see how it's all, the lines are pinching right there? That's going to compete. The effect of volume, you know, the cross contours creating this sense of volume is going to be competing with something like that, where everything comes together in a way that it wouldn't, kind of flattens out the top and it creates some competition. So I'm going to go ahead and just correct these lines. And I know I said 15 lines, but I was really expecting you guys to do your still lifes as big as the drawing space, and that would have given you room. A lot of you did tiny still lifes, and then so adding 15 lines was very challenging because you weren't really taking up the space of the drawing space very well. You're just kind of like using one small part of the area. Some of you did take up the whole drawing space. But a lot of you just drew very tiny. So that's why it was challenging to add 15 lines. And I put 15 lines because if I don't give a number, then some students will put like 1 or 2 lines and call it quits. And I just wanted to kind of avoid that, and then overcompensated with giving you too many lines to include. Okay, so again, so I'm going to go over this in black at the edges, just so you see that curvature that's happening right at the edge. Okay. It's not flat, it's curved. The behavior is this. See that? That's the behavior that we're aiming for, that curvature. Okay. So you're trying to convey this. Okay. Okay, so for the planar surface, I have a little nifty ruler, and I'm going to use green this time. So I'm gonna guesstimate that the horizon line. I'm just going to put in this example, when you have the table surface, the back edge of the table surface doesn't mean that's the horizon line, because if you remember your cubes, the back edges of the squares didn't line up with the horizon line. The converging lines created the horizon line. So the back edge of the table is going to be like somewhere around here. I'm not looking at the original source, so I don't know. I'm just guessing. So this is the back edge of the table, not the horizon line. The horizon line is going to be, if you see, you know, and the tops of these bottles are incorrect. They really should be starting to point back down instead of up, because the horizon line is really going to be around here. So these should be pointing down, not up. Don't worry about that. Okay, so I'm going to put the vanishing point here, and the cross contours that would be on the planar surface would follow some form of linear perspective. In this case, 1 point. And as you go further back in space, things get closer together. They're still converging on the horizon line. The lines are just getting closer together, because as you recede in space, everything gets smaller. The spaces between things get smaller. The lines go back and converge. And if you look at two lines converging, so I'm going to go ahead and draw, oh, this is making me so mad. It's like very frustrating. I'm going to go ahead and put full lines and show you them converging. So look how the space between those two converging lines, the space between the lines is getting smaller. That is a reflection of how everything, objects, everything, as they recede in space, get smaller. The further away they are from you, the smaller they are. Oh, I hate this. It's very frustrating. I don't know why it won't twist. Okay, and so the same thing applies when I go to do the horizontal cross contours. They're going to be spaced closer together towards the back. And as I come forward, they're going to be further apart. Now, there is a very specific geometric way to measure this so that these spaces between converging lines, equally spaced converging lines, the space gets smaller in an accurate way. But if you understand the premise, okay, so if you understand basically the premise of what those lines do, can you see how it looks like it's like the surface is flat going back in space? It looks like it's going back in space. And so these objects look like they're sitting on top of a table that is flat. I mean, that is like has depth to it, and the back of the table is converging on the horizon line. Okay, so this is, you know, each one of you did a version of this cross contours, and so I'm not gonna go over every single. I'm not going to go over every single image like this. For many of you,